grass, and this vibe series is about connection, bringing people together from across the land-based sector and bioeconomy to share some ideas, challenge thinking, and spark meaningful conversation. The topic sits at the heart of some of the most important conversations we're having here in Aotearoa right now. Pasture-based systems are central to New Zealand's food production and food system, yet the role of nitrogen, how it moves through soils, plants and animals is often misunderstood or oversimplified in the wider debate. Today is an opportunity to bring together science, experience and practical insight towards that. This session comes in two parts. First of all, I'd like to introduce Emeritus Professor Keith Cameron. Keith is a foundational figure in soil and environmental science at Lincoln and beyond, with a career dedicated to improving our understanding of soil-environment interactions and translating knowledge into practical solutions for more sustainable agriculture. Keith will very briefly set the scene from a Lincoln University perspective, highlight some of the work underway, and then he will connect and introduce Adjunct Professor Jacqueline Rowarth to speak to you about this wider conversation of less gas, more grass, and rethinking nitrogen. Thank you.
Tēnā koutou katoa. What a pleasure it is to see so many Lincoln graduates, friends of Lincoln, research colleagues here this afternoon. Thank you for making the time to come to hear these talks today. Lincoln has a long history of research into nitrogen and grazed pasture systems. Over 145 years of science at Lincoln. This is the class of 1890. You remember them? Don't you stole my joke? The gentleman with the bowler hat here and the doorway is William Ivey, who of course was the first director of Canterbury Agricultural College. Now, following up on George's lead there, you may be aware that I've been a Lincoln member of staff for over 45 years now. And I swear that some of these young students today think I was in that photograph. Lincoln University motto guides what we do at Lincoln. And underneath the crest, we have the motto, which is translated as science and industry with integrity. Science and industry with integrity. So I would like to take the opportunity to thank multiple partners and collaborators in the research work that's being conducted at Lincoln over decades in this particular area. Science and industry with integrity. That's what delivers impact. That's what delivers results. That's what gives technology to farmers to achieve economic success and protection of the environment. History shows that it has been a continuous journey of nitrogen discovery and solutions. With the early foundational work starting to look at improving pasture performance. In fact, William Ivey, some of you may or may not know, was the first person to import superphosphate fertilizer into New Zealand and to use superphosphate to boost pasture production. Following from the foundations, Professor T.W. Walker and Professor Langer were appointed to Lincoln staff in the 1950s, 60s, 70s. They were here. And they made an enormous acceleration of our understanding of nitrogen fixation by clovers for grazed pasture systems. In the 70s and 90s, the focus was on nitrogen cycling in moss seeds, measuring those. Scott Black, Rob Sherlock, in particular contributing in those years. In the 1990s to 2010, environmental impact was becoming more and more apparent. The questions were being raised by the public about the impact of agriculture on the wider environment. And so Paul G, Tim Clough, Grant Edwards, Jacqueline Rowarth, Derek Root, Nick Lucas, Rachel Bryan, Omar Al-Marisday, and this guy again, all made some contribution to this direction. So Lincoln continues that history, and we are now focusing on farming solutions. And there are many PhD students and master's students who have made significant contributions to those developments too. We're still researching across biological nitrogen fixation, nutrient cycling, nitrate leaching losses, ammonia and nitrous oxide gas emissions, fertilizers, improving fertilizer use efficiency, minimizing environmental impacts, nitrification inhibitors, nitrogen management and mitigation, and of course pasture animal systems, where we're trying to improve our understanding of the whole system. Lincoln staff and students have made major contributions to these national nitrogen research programs in collaboration with DairyNZ and Fonterra, many other collaborators around the country, Massey, etc. Pasture-21 research program, forages for reduced nitrate leaching, abbreviated to FRNL, planting potency, low nitrogen loss farming systems, and the discovery and development of nitrification inhibitors. Over the past 10 to 15 years, there's been considerable investment in economic terms and in time to try to find answers to these challenging questions of how do we improve our profit from our farming systems and at the same time protect the environment. Evidence of this impact by Lincoln University is there's over 150 PhD and master's theses in the Lincoln University Library on the topic of nitrogen in grazed pasture systems. 150. And over 1,000 peer-reviewed publications in our library from our staff on nitrogen fixation, cycling, gains, losses, leaching, ammonia volatilization, nitrous oxide emissions, fertilizers, inhibitors, and whole farm systems. So from a historical perspective and a current perspective, Lincoln University is making contributions to help globally address some of the challenges of nitrogen losses from grazed pasture systems. And so it's my pleasure to introduce Adjunct Professor Jacqueline Rowarth as an expert in this area. Jacqueline's exceptionally well known across New Zealand and internationally for her work in agricultural science, soil systems, and most notably in science communication. How many of us have managed to communicate into the media as effectively as Jacqueline? Jacqueline's worked across research, education, and governance throughout her career and has made a long-standing commitment to helping the public better understand the realities and the importance of agriculture and food production. But importantly for us today, Jacqueline brings deep expertise in nitrogen cycling and pasture-based systems and a strong track record of engaging constructively with some of the most contested conversations in this sector. Be fair enough to say? Yeah. So we're very fortunate to have you here this evening, Jacqueline, and even more fortunate that you want to bring your experience and evidence-based perspective to today's discussion. Jacqueline will explore the role of nitrogen in pasture systems, how it behaves in the grazed environment, what happens following urine deposition, how some of the assumptions and environmental debates have developed, and Jacqueline will be open to discussing different production system approaches and some of the big what if questions facing global systems. So I would ask you to please join me in giving a very warm welcome to Professor Jacqueline Rowarth.
Thank you very much, Keith. And friends, colleagues, Cantabrians, lend me your ears. I come to bury some myths and perhaps to explain them. I'm always open to questions, and my main role has always been in the classroom or talking with society in general is to say, how do we know that? Are we sure? So today I know that I'm speaking as part of a suite, and there will be people who have far more expertise in particular areas. And what I really want to do is crack our thinking open so that we can ask even more searching questions of Keith when he does his talk. I'm in agriculture to save the world. Quite simple. When I was at school in my final years and during the early 70s, I decided that because of overpopulation and the issues with food production, we might like to think about how we were going to feed the world. And for me, it was about sustainable food production. So no, I didn't go into environmental studies. I went into agriculture. Did a year's farming practical on an organic farm in the UK. Parents saw the light, brought the family out, did a year in Awakino, sheep and beef, and then came to Massey. I saw the light and came down here in the 88. But in Massey, that's where I did a PhD in nutrient cycling after honours in environmental agriculture. And for me, it took me, well, another 10 years to play St. Joan, but it is all about a commitment and helping other people to see where we might be able to make progress in the future. No, I don't fancy being going to the state, but, you know, it happened on stage on a nightly event. For me, it has been about production because, well, we're now at over 8.5 billion people in the world. And I think when I was making my decision about agriculture, it was only something like 3 billion. It's extraordinary that we have managed to go on feeding to a better state of nutrition more people in the world. Yeah, we've dipped since about 2015. COVID didn't really help. So we need another boost on how we're going to be feeding people. But we have to do it by protecting the environment at the same time. It's always been for me about economic viability on the farm so that we then have sufficient money to put in new environmental technologies that protect our natural resources. And that's called the productivity that New Zealand, that the world actually really needs, because our biggest threat to biodiversity is actually agricultural expansion. There is research on it. So at this point, I would like to say that the joy of being an adjunct professor at Lincoln University, I taught here from 94 to 2000, is not only seeing past students and colleagues, but it's also the fact that they give me library access. Somebody changes hands, you know, nothing dodgy, but library access for me means that whenever I hear something and think, well, how can that be right? Or was that really what that paper said? I can go through the Lincoln system, thank you, Grant, and find out and get the actual paper and see the actual data. And sometimes that's going back to first principles. And with nitrogen, one has to keep doing this because nitrogen is pretty much simply the most contentious issue you have with the category planes, mostly because of the immediate, it's the black and white, the cows that are the problem. So I'd like to challenge that. We know that nitrogen pretty much underpins the world food supply. The Haber-Bosch process is estimated to feed at about 50% of the world's population. I know that there are people who say that organics can feed the world. You check their calculations. They aren't right. They're not taking into account the greenwash nitrogen that goes through the grass that then is fed to the cows, and they say the grass that's fed to the cows goes onto the organic fields. But where did how did the grass grow in the first place? Almost certainly urea. And we know what happened with Sri Lanka when they decided to be organic, and that legacy is with them still. So that's 50% of the global population. I have no children. If we want to go organic, that's fine. I'm prepared to be pop myself off in the half that's going to go, but I've never met anybody who would join me. Not once. So what are we going to do about actually feeding the population? And what we do with nitrogen is increase productivity. Now, of course, we try and do that efficiently. And of course, as Keith has said, there's more and more work about trying to get the nitrogen into the plant, into the animal, it's not the animal, into the human, in the efficient way. But then some of it comes out at the other end. And how do we manage that? There will be people after me talking about things like that in this whole suite of things. Because the other thing we accept is that nitrate in water has increased. And Greenpeace very helpfully has told us where. Greenpeace has done this, bring in your nitrate, your water from your tap, and we will tell you if it's high, low, extreme or whatever, and they've plotted a map. And then they've very helpfully alerted us to all sorts of what they term emerging research about health links. And when they do this, I like to validate, verify. I don't have to go through Lincoln University to do this because the Ministry of Health has very helpfully got a cancer website, a cancer data web tool, and you can put in what sort of cancer you want to look at. And you can say, I'm looking at a particular gender or a particular area, or a particular age group or ethnicity, and the data gets spat out. The Ministry of Health, the latest data in 2023, says that colorectal cancer is high in Taranaki. That's just in case you're all from the South Island and don't know where Taranaki is. Or South Canterbury, Northland and Bay of Plenty. And we get told that there's correlation, and I can't see it. Colorectal cancer, it's not high where the red spots are high. I'm sorry if anybody has it. Of course I am. I don't want anybody to get cancer. But let's not pick on a thing as an identification that is actually not true. Last week, they started talking about stomach cancer. You see that research? Again, it's Danish research. So they're saying there's a link between low levels of nitrate in water and prevalence of stomach cancer. So immediately I go to that. In fact, it's so low in New Zealand. It's about 400 cases a year that are noted, registered, and find that on the stomach cancer website, 400 issues are smoking, obesity, and alcohol. And I'm sorry, it's 3 times as many Pacific Islanders and Maori as Pakeha and Asians. But again, nothing to do with water, but watch the news, it's in there already. Blue babies, methemoglobinemia. We have got a register of one child dying in East Anglia. They think it was microbial contamination so E. coli with the nitrate water. Just keep sterilising the bottles because that becomes the issue. Preterm, it's ethnically linked all over the world. It's ethnically linked in New Zealand. Obesity, alcohol, smoking, and partner abuse. Nothing to do with nitrate. So we were happy about that. Every single piece of research on this says there seems to be some new data coming out. It doesn't look totally convincing, but perhaps we just better make a statement to be sure, because nobody wants a child to die. The preterm, that it's anything below 38 weeks. And the underweight thing's really interesting. There is a statistical significant difference with high nitrate water and underweight babies. We're talking 9 grams lower weight, and a baby is 3,560 on average. So I'm not sure that 9 grams would be likely. We love that so far. Everybody happy about the health issues, and we'll move on. So is it actually a problem? Yeah, because I don't want anything from my farm leaving and getting into the water. I'd rather have the nitrogen in the grass and moving into the animal. The farming I'm involved in the Waikato is intensive dairy. So we're managing the animals' health all the time. And there are deer some of the area as well. So we're managing the pasture to ensure that it's always top quality. Because we have a shelter, that's why Capo gets a bit hot in summer, as it does down here. We can collect the nutrients in the shelter and we can take them to the maize. So it's a low nitrogen loss system. And then the maize comes back to feed the cows. And it's a low greenhouse gases per kilo of milk solids, but not as low as you can get in Canterbury with irrigation and water. You have the dairy cows here are the lowest impact in New Zealand. Well done, the contaminants. Less gas if you feed your animals so that they are producing milk. More grass, that's what feeds the animals, or the maize or whatever. But I'd like us to be rethinking nitrogen. And I'm always happy to answer questions. Can't see anything yet. Because we need productivity desperately in New Zealand. And let's research on this. 70% of people in New Zealand, they know that agriculture is good for the economy. 22% don't know enough to say anything, and 8% say it's not good for the economy, thereby proving they know nothing. That is labour productivity in agriculture over the years since 1996. Well done to all the scientists and extension people and companies and farmers in New Zealand, because that is service industries. That, where we've got a measured sector, that's everybody, and down here is goods producing. We are fantastic, and even better. Look at this. For last year, multi-factor productivity fell in New Zealand except for agriculture. Can you imagine what the figure would be like without agriculture? And that's just agriculture. The primary sector is there as well. It's actually not quite as high as agriculture because mining's in there. But what we're doing, all of us working together, is creating a system that the rest of the world finds difficult to beat. We've got those data as well. We're at that, so DairyNZ, puts them out, you can see them. We produce fewer greenhouse gases per kilo of milk solids than other countries. And this graph from DairyNZ LRC, latest data 24-25 on the mid-1990s. I look at this and think this is fantastic. This is average kilos of milk solids per cow. We're feeding them better, we're breeding them to be great performers. They are our All Blacks and Whites of New Zealand, elite performance athletes. And here, kilos of milk solids per hectare. We're measuring that grass. We're making sure that it does have the water and nitrogen and making sure it grows, and we're working on harvesting it ever better with new technologies. And when I look at that graph, I think, my goodness, we're feeding so many people what they need to eat. All those 8.5 billion people, when you look at what milk is and what meat is, the essential amino acids or the indispensable amino acids, we do it through milk. And Graham Cole, sitting here in the second row, he's calculated that we feed almost 1% of the global population their essential amino acids just with milk. I'm not getting into the meat part for the carbs and the dairy beef or the carcasses, and for less than 0.04% of the global greenhouse gases. That's fantastic. He's also calculated that for the Canterbury Plains, I'll come back to that, sorry. Here is the milk, all usable. So 3.7 grams of usable for 42 calories. Anybody tried quinoa? Look, you have to cook it for only 20 minutes. It's one of the least difficult things to do, but you have to add an awful lot of things to make it edible, or just boring, but to make it actually tasty. Thank you. And you're going to eat 3 times as many calories. That's not good. Some work in America did calculated all of white. They said America could get rid of all the animals and grow more food. We'd probably have 23% more food. But overall, Americans would not be well nourished because they'd be eating too many calories for them. And frankly, they're already eating enough. And that's the problem with plant stuff. You have to eat more to get the indispensable or essential amino acids. You break down the non-indispensable ones for energy, and the nitrogen you haven't used goes through the sewage system, and greenhouse gases are worse. I think you should talk to Graham, it's right here, after the talk, before you have dinner, because he's done the calculations, and vegans are worse for the planet than vegetarians or omnivores. Good to see some nodding. And nobody should listen to Greta Thunberg. It was only 16 at the time, yet people believe that. Beef, that's pretty good as well. It's what we do in New Zealand. It's producing the high quality animal protein that people need to be healthy and to manage their weight. We know it's actually quite good. Any of these GLP-1 drugs, they're actually quite good for us because people need to be eating high quality protein. Because they don't want to put on more weight. And that's what will happen with eating. And what I ask is, when everybody knows something, everybody knows, how do they know it? And for me, I'm assuming nothing. The Canterbury Plains are a beautiful patchwork of many different soil types, heavy, light, organic. They are a result of farmer activity, remembering that farmers in New Zealand are not subsidised and directed by the government, well, they are directed by the government to do particular things now, but they're not subsidised to keep them in a permanent state of unproductivity, as they are in my home city, country of UK. What they have done with the Canterbury Plains, Keith highlighted some of it, is realise that they were phosphate limited, so they brought in super, had some flood irrigation, and super allowed the legumes to grow. Keith mentioned that. And then as you're growing more, pasture starts building up. Subsidies came off in 85, but as sheep farmers couldn't make honey, they thought, what else are we going to do? Some of them sold because they didn't want black and white cows, and others decided that's how you make move. And some of them stayed in and cropping, but they also had fattening, dry scale, winter grazing. So it's been a really good example of a combination of management and environment. But on the Canterbury Plains, in this wonderful braided sort of system, we remember history, but in about the 1940s, the minister, vicar, being sent down from Wellington to look across the Canterbury Plains and say, what about settlement? And he said the problem with the waving grass and the sparkling blue water is going to be wood. So they planted macrocarpus because they're multi-purpose. And there was a Fulbright fellow who came here in the 1990s, geography in Canterbury, who said, and macrocarpus are looking a bit old, they're going to start, falling down in the way that they do. There's going to be a fuss when they came down, and lo, there was, because when dairy started coming in the 90s, the macrocarpus were mature, they disappeared, and people blamed dairy. Right. And they started blaming dairying for water as well. But we have information. John Marshall was Crop and Food, and he did some work on the Leaston Drain and measured nitrate and various other things, because he could see great nasturtium officinalis, what do I mean, watercress beds, and people, dairy sheds being discharged into the stream, and he could see the septic tanks and the little villages. And 1K from the source of the Leaston Drain, which is just a bit northwest of Springston giving the clue, 3.6 parts per million. Remember, 11 is the idea of nitrate. Dropped to 3.3, dropped to 1.4. By the time we got to what was then called Lake Ellesmere, it was right down at 1. Happy? It's not exactly 0, but it's 1. And what was happening, it came out highest. We can see from the phosphate, my mother had fed me better in utero, 15 as it comes out in spring, suddenly at 55. Oh, dairy shed effluent and septic tanks. Dropped down through the watercress beds to 13, suddenly up to 33. Listed septic tanks. That was in he did the work between 72 and 73. So let's not make assumptions, because septic tanks are a major problem. Graham's got contact at the Selwyn District Council and was given the information of 36,000 people on septic tanks. So he did the calculations of how much nitrogen was being excreted per year. And Selwyn District alone has 183 tonnes going to groundwater. Okay, just hold that thought, 183 tonnes. I've just been talking with Hamish Gower in a first year class, and he's got all excited about doing the septic tank and lifestyle block calculation for New Zealand because he thinks it's a ludicrous high quality land. So we are part of the problem, people. Of course we are. Then there's gorse. And Landcare did some research that said, you know, gorse is contributing a lot more, and look at the gorse on the Canterbury Plains, Banks Peninsula, a lot more nitrogen than anybody is actually realising. And if we don't get a handle on this, we're going to start constraining agriculture. Like it so far? Because we've also got data right from, this is Catherine Rutter, who did this for her science fair, working with her mother, Helen Rutter, which was with neighbour at the time, right from, frankly, almost before I was born. And the data showing that right then, 1955, we've got, so we're down to the 1960s, high nitrate water in the 30 to 40 metre depth of the wells. And certainly there are more records of it now because we've been taking measurements more recently. So when Greenpeace says lots of wells, look, they get confused between how many wells and how many data spots there are. Remember I said the subsidies came off in the mid-80s, and that's when the dairy boom started, sort of around here. You can see that there was higher nitrate during the 80s than there is now. And certainly that some things are increasing, but we do need to consider what the Rutters said, which was that actually we can keep an eye on it, but we shouldn't be pointing finger yet because there are clearly earlier land managements and point source discharges, and they weren't looking at the whole septic tank issue or the basic background, because the basic background is quite significant, and it's the organic matter. Remember I said we've been building up the organic matter, and lots of piece work Keith and I published together, we've shown that the organic matter is the bit you can't control really, because it depends on temperature and moisture. And this work was done, Dennis Curtin at Crop and Food, and he showed that under cropping, because it has fallow bits or tines, you can lose 100 kilograms per hectare then here. And if you take away the plants, my point of view is when you've got irrigation, you're keeping the plants growing and taking up the nitrogen. If you've got nothing there, you lose a lot. Love it so far? Because it's the least easy to do anything about, because we want organic matter, and you know that all the regenerative agriculture and organic people want a say, build up your organic matter. Okay, well you can to a point, but you do need to think about the unintended consequences. And then we come to the urine patch. I love the urine patch. I'm assuming nothing, because everybody knows, that's a fluke, that up to 1,000 or more are the general statements, and it should be then equivalent, but somehow in some of the activists it becomes we're putting 1,000 kilograms of nitrogen through cow urine on a hectare. We should be getting the clue here, look, 1,000 for cattle and 500 for sheep. Well, that's convenient, isn't it? So Graham and I and some others here did some backing, real searching to find out where this came from. And I go back to 1969 in America with total mixed ration cows on very strange flooring. And there was another bit in 1985 where they were trying to look at the urine versus the fecal matter. But note the urine concentration of 10 and note the assumption for 0.2 meters squared for an area of cattle urination. Anybody been in a dairy shed recently? 2 meters to 0.2 of a meter? I haven't milked for 1 year, 11 months, 3 weeks and 5 days. But I know that the area, if you're on pasture, is 0.2. And if we look at Rachel Ryan's work with students at this century, we can see that the concentration, and there's work at Massey that supports this as well, and DairyNZ, is actually almost half what was used from the total mixed ration cows from America. And we can see that the patch area is twice what was found on the sand farm or sand or sawdust in America. So most of you have done the maths already. It's not 1,000, it's more like 250. Half the concentration, double the area. So all that, and Sherry Melvett up with Ag Research showed that there was a much bigger zone of uptake than just the area that was hit. And there are publications trying to explain this. I'll be very happy to share them. And in fact, True and Dick Haynes's work the next year took actual urine and did that area. And so they were applying in their research the equivalent of 280 kilograms per hectare. But you know, that's just not as round a figure as 1,000, is it? But man, it's ended up with some misunderstandings. Everybody happy? Because then there's Jim Moyer's work with, good heavens, Keith and Cameron and Dee Hong-Lee, who showed that actually within a year, the pasture hectare does not get covered. It's only about a quarter of the area, a quarter. And the very little double up, they actually did the calculations, even fewer triple ups. So then we can apply this 0.23 to Prue Williams and Dick Haynes' calculations, and they actually measured 11% of their 280 kilos below 600 mils. And if you consider then about the 23% of paddock, that's 7 kilograms per hectare a year from a pasture that's grazed by dairy cows. 7. And it was 100 from cropping. I'm sorry, Foundation for Arable Research. I really am. But what we're trying to do is actually get some understanding, and some work on the Canterbury Plains has shown, it was Graham Coles, John Porter and Steve Rackett, that the best use of the Canterbury Plains is dairy cows with a bit of arable. And the calculations, again, Graham's calculations, he is a nutrition scientist. If you're worried about your budget, 6 cheese sandwiches will give you everything you need. What did you suggest? A bit of the lemon juice? A bit of red pepper, 6. That will give you all your nutrition for the cheapest diet you can have. Sounds okay to me, but I'm vegetarian. So Haynes and Williams said its rapid plant uptake makes the difference, minimising leaching losses. And then there was Tim Clough's work, which showed that even during winter, and actually Prue and Dick's work that showed the 7 kilos going, that was done during winter as well. Plant uptake of urine 216 kilos to 314, sandy loam. But they had put on 1,000, and the thing, if you can just imagine, that if there is a cup here, and that's what the plant can take up, if you don't overflow it, it's in the plant. If you put on 1,000, there's an awful lot that's got out. And even that's not ending up right away through to the groundwater. And we know this is the case. Poor old Golden Bay farmers. They're in the Waikuku Springs catchment. They've got the most beautiful, purest water in the world. There was a whole environment court case when they were asking for more irrigation because they were getting dry summers. I was there saying if they have more irrigation and don't let the grass, they have the irrigation to keep the grass growing, the nitrogen from the cows will go up into the pasture. If it gets dry, then you can have a problem when the water comes again. And they were told, no, you've got to cut your animals, you've got to cut your fertiliser, and they've reckoned that they've done all that by about 20%, and there's been no change in the water quality because it's not coming from the dairy cows per se, it's the organic matter. The gorse that's up the hills, the septic tanks, because everybody loves living in Golden Bay, is going to holidays there. So you will get the details of everything, the actual pasture uptake or drainage or the roots or whatever, but our general thing is if we've got more nitrogen, we've got more roots and more pasture, we can feed our animals better, being there, you know, all black and whites. And we can reduce, particularly if we've got precision irrigation, we can reduce anything that goes below the rooting zone. We haven't done that with septic tanks because they discharge at 30 centimetres, which is below the rooting zone. And that's a big source of nitrogen. Right place. This is the standard mantra for fertiliser. Right place, right time, right form, right quantity. So I spent, my PhD was in fertiliser and moving around hill country and coming down to the Canterbury Plains and doing the nitrogen, getting it right, which sometimes means starting again. Precision application, because it was Rob Sherlock's work that showed that a transition from ammonia to nitrate at 2.7 degrees took 3 hours or something ridiculous. We've got very active soils in New Zealand. Improve the harvest of material, so with our dairy cows or our sheep and beef, all the new technologies like AIMA and Halter, E-Shepherd or whatever are helping us with pasture management. And it's all about, for me, productivity. Are we more productive by using regenerative agriculture or organics approaches? Well, we haven't any data to support that, but I would never say to a farmer, you can't be that. I would never say to a person, you can't be vegetarian. I would, if anybody's going vegan, have a little consultation about that. It's not for good for your health. But more fallow and reduced yield. So we go right back to the fact that we've got more and more people coming. And if we don't feed them from our existing land, we have to take out new land, and that's the DOC estate, and that's biodiversity, and I don't think it's a good idea. But vegan diets do result in more greenhouse gases, and what we're trying to do by feeding our animals better, ever better, is reduce the greenhouse gases per unit of production. So my take-home thinking. It's a result of many processes. There is no simple answer. Just getting rid of dairy cows or any animal will not help. We have got the match patches, we've got the data, and if we really have an aspiration to improve wealth, we're going to need the primary sector. We know that scientifically backed intensification, the work of the levy bodies, the work of the universities, the work of the Crown Research Institute, now called public research organisations, it will give better economics and protect the environment through biodiversity. And the scaling up that can be done is probably dairy, possibly kiwi fruit, but only in certain areas, dairy, and better work with beef, dairy beef, to be able to use all the parts. And we need to think differently. So rethinking nitrogen is what we're all trying to do in the soil science, plant science, animal science area to feed people.
Jared, really interesting thoughts there and an opportunity for questions. But I'm going to hit you first off with a question in regard to the science funding in New Zealand. And you've alluded to the fact around.
I just try now.
Yeah, but you've alluded to it at the start of your presentation around the essentially the role of research in driving productivity, economic growth, in particular. Yet the reforms of the science industry funding, science sector funding in New Zealand have deprioritised funding associated with both the bioeconomy and environmental industries and also environmental resilience. What is your perspective on that and the nature of the conversation you've just had which has emphasized the absolute importance of nitrogen for dry development, not only in New Zealand, but
across the globe. So it just makes me read what's happening in terms of funding and how do we go back, because it's right through the education system as well, that our only comparative advantage is the primary sector in New Zealand. We haven't got any rockets, for goodness sakes. Our comparative advantage is our primary sector, which means soils and plants and animals and the environment. That's what we've spent our life doing, is it not? And if we need to get through this message, because what the current research is showing, and some of you are aware of it, is that we've actually hit a bit of a plateau because of the increased carbon dioxide. We're hitting a plateau with our forests and our pastures, and part of this is there's more carbon in the plants and they're locking up more nitrogen, etc. It's not breaking down as fast in the soil, and we're simply not getting the growth that we should be getting. And an awful lot of people saying, if you give me this money, I will be able to do, are using old models that simply aren't right at the moment. We need to go back, pretty much back to the basics, challenge the assumption that we've done the pasture work, because we haven't done the soils work, because everything is changing. How can you build a model when you know that everything is changing in the way that the government keeps going on about as well? And if we don't get the education right, that's just tragic for our children.
Thank you. Opportunity for questions.
Could I just offer a little follow-up to your question, Grant? When I joined what was then DSIR Crop Research Division in Memorial or Remembrance Day 1974, one of the first things I heard was we could stop doing anything in the division and just devote our funding to making sure that what we'd learned is adopted. We could increase New Zealand productivity by 50%, and that has not changed in the last 50 odd years.
So one of the first things that happened with the funding was actually we were stopped doing things with farmers. So when Phil and I were working in the Canterbury Plains with the ryegrass seed crops, we were out there with farmers making a difference to their bottom line, seeing what they were doing, and then going back to the trials and thinking, gosh, what they did, would that work? Why can we work out what the driver, the change was, so that we can then apply it elsewhere? And if it was just a completely local thing, maybe not. But that's the point, was we were able to do the research, and the funding, we know, is dismal, dire and dreadful. Peter Gluckman said it enough, so why can't the universities and PROs get together and the levy bodies and stop it to them? If we all said there's a problem, maybe we'd get somewhere, but it's going to take a concerted effort from all of us saying, we can't help, New Zealand's goal of productivity if we don't have the funding to be able to do it, and therefore the encouragement to the next generation who are being told that creativity is enough. You've seen the OECD stuff, just injecting this. We keep being told that the new curriculum therapists will change, they won't be as creative. Okay, so we're about 7th on the creativity list. Singapore's first, and in maths, and in reading, and in reading, writing, and followed closely by career. It's just nonsense what they're going on about.
Okay, more questions. Thank you, Ava. Please.
Thanks, Jacqueline. While I agree with the first part of the presentation, it's definitely in New Zealand we're doing much more, or we're not doing as harm to the environment as other countries. I'm not sure about that. Those calculations you showed for the urine patch, and my question to you, we just wrapped up a farm system study. It's a self-contained farm system study at the LURD, 4 years, where we used more than 700 suction cups drilled to more than or close to 5 hectares, measuring nitrate leaching. And in the ryegrass white clover, we measured 20 kilograms of nitrate N leached per hectare every year. This lined very well with the overseas values of around 22, where overseas is using 750 kilogram of N per urine patch as N load from a cow grazing standard dry grass whatever pasture. So my question to you, how you explain that? So also there's another project which is as part of this, the farm system study I just mentioned, that's part of the plantain potency, and these numbers also align with the low-end farm system study that's currently happening at the UID.
The reason we do research is to work out where the changes are and to see where the data go. Now, I think Overseer is calibrated at 700, and if we tried it at more like 280, 300, you know, the figures we're getting at the moment, it would be interesting to do the comparison. But off the cuff, I can't tell you exactly what the difference is because I need to look at your grazing patterns, the amount of growing, what your harvesting system is, all of those sorts of things. But that has been my role in some of the other research we're doing to try and work out what the differences are and how we can do better.
Thank you, Emma. More questions, please. Richie Christie, thank you.
Just going back to your lovely diagram of Canterbury, I just wondered if you've got any comments on the hello Tiwai Ora, the way of consciousness.
Well, back in the old days when it was called Lake Earls, people didn't like swimming in it because there was no visibility. And I didn't actually check the date on that map. So mostly what I saw is that there's quite a lot of sediment in it. And, you know, there were some deep bits. And I remember Prue Williams, who's the urine person, saying she managed to fall into the deep bit and everywhere else it was shallow. So what we've done with that lake, I think, is try and muddle up the hydrology. And part of it's not letting it breach and clear out. But there has been this phosphate that's the problem. Remember I showed you the phosphate things? And they cleared the nasturtium of this, I keep forgetting the real word, watercress beds, so that there's more phosphate getting in there. Remember, our lakes are usually phosphate limited. And phosphate is a human problem. And you know what the data from Rotorua, and they've been taking away all the buying out the farms from Rotorua. Have you looked at the quality recently? It was septic tanks and the sewage from Rotorua that was causing the problem. It's got to be years before it gets better. It's fine. Within 10, they had you know, it's just, we get in a muddle because we make assumptions. And that's why I'm assuming. And I work with people, some of you are here, published with lots of you here, who actually keep their brains open and say, why would you think that, Jackie? And sometimes I think, oh, gosh, have I made it? That's terrible if I've made an assumption. But let's keep our minds open, go back. John, I can't see John Harris. He was going to be there. He won't make his mind up about anything. The same with Tony. Well, no, I haven't read all the papers yet. Okay. Because they go back to first principles. And so that was the date of 1,000. Go back to first principles and do the calculations. And it's one piece of research, but it's sort of backed up by more things. And there were several papers presented at the FLRC conference, and Cecile de Grine's student was talking about 260. And I said, where did that figure come from? And she said, well, I collected it. It was real amount, real concentration on a real area. So we get in a muddle, no assumptions.
Thank you. An opportunity for a couple more questions before we.
These are the short ones, like Stephen Goldson. That's okay.
Can I make a general comment about the political environment? And I think it's very important. I think this is important around the funding, because there are those who think AI will fix this stuff and will reduce the research because AI is going to do it. And I think this is something that we do need to push back. Jacqueline, what you're talking about ain't going to be fixed using AI.
Getting stupid.
And I think it is now being talked about in Wellington places as a reason why they can cut back on discovery research. And I think it's important. That's not a question.
Thank you. Steve. An opportunity for one last question here before we have some drinks, and then to Jim, and then we'll finish off. Thank you.
this is a wee bit off the nitrogen topic, but I was just interested in your views on planting trees, right place, right location. It's just and how that's affecting the carbon. Views on that.
How they fix the carbon?
No, I know how to fix carbon, but do you think that's, what's your view on the planting trees throughout New Zealand on mass sites? How that's affecting?
So the forestry,
yeah,
it's extraordinarily short-sighted. I was a parliamentary commissioner for the environment who said don't use it as an offset because it's short-lived and then it has to stay there. And then, so I think it's mad. And Singapore has done some interesting work with cellulose and making stuff with it that you can eat, but it's spaghetti stuff, you know. But you know, spaghetti, actually it's the sauce that goes with it that makes it edible. So is it actually a sensible way to do anything? No. So no, I think it's totally distressing. We could get into the hacking out of rural communities and the closing of schools. And what we know about Southland is that it got reinvented by the dairy boom because the schools came back and the medical people came back and they're thriving. They've even got a thing called Thriving Southland. I was down there last week, during which recently finished Special Envoy for Agriculture, good Lincoln graduate Hamish Marr, said the government should be regarding dairy as a strategic asset. It's a national component of our budget. And you know, the dairy beef and all of those aspects, we are integrated. And the reason we're integrated is because people in New Zealand see opportunities and then think, could I do that? Would it work? What's it like environmentally, economically? I'm in. Or not for me, and they say.
Jim, last question.
Jacqueline, thanks for your talk.
23%, Jim. Of course, I quote you. You got it right.
So, got me thinking, when I did my undergrad degree,
Thank you.
the new technology on the block was urea. And it was a big thing. Today, unfortunately, yes. Today, farmers face nitrogen fertiliser caps. What do you think the impacts of those caps will be on New Zealand pasture?
The cap, the 190 kilos per hectare cap that was brought in when by the previous government was predicated incorrectly on a misinterpretation of a graph that showed a decrease in rate of increase, not a decrease in production. So they misunderstood a rate of change graph and a change graph. You are just infuriating me, that's all I'm saying to you. They are allowed to use organic forms of fertiliser because organic nitrogen doesn't leach since when? Honestly, since when? So organic forms don't count in the 190. I think what we're about to see, because remember the clovers have picked up tremendous, but clover is a 3 to 4, possibly 7 to 8 year predator-prey cycle, and we're about to see some drop-off. And my concern is that in a good producing Canterbury farm, you're taking off 120 kgs of nitrogen in the vat, you know, in the tanker every day, in over a year. And then there's the animal components as well. I'm concerned we are going to see an erosion of the organic matter that we've been building up through the super and the irrigation and the nitrogen over the last 30 years, or is it 40 or 50? And when I was teaching here in the 90s, one would wake up. You remember the dust storms? You wake up thinking, when was the last time you saw a dust storm on the Canterbury Plains? That's the organic matter. That is the irrigation and the pasture and the judicious use of nitrogen. And yes, we may well have used a bit more than necessary in the past, but you will find tons of nitrogen in that organic matter. And if we start losing that, that's what I'm concerned about, then there'll be more nitrogen. And I wrote about this once in some article, and Mike Joy, and I quoted Tony Parsons at Massey University, and Mike Joy took him and Tony's not very big and Mike Joy is bigger. Jacqueline says that if we change to beef sheep farm dairy, we'll lose nitrogen. And Tony said yes. Well, that can't be right. So he took him through the whole calculations, but he didn't want to know. His brain is not open. So, and that's why if somebody comes up and says, "The terrible problem with nitrogen," oh right, that feeds half the world's population. That sort of thing. But the technologies are getting better. Precision agriculture is part of what we need to do, and focus on the best things we can do, which is the protein, animal protein, high quality protein, and get that message, and particularly about funding, because AI is not going to solve it, and nor will the use of old models. Thank you very much, Brian.
Thank you, Jacqueline. To Professor Keegan. Thank you very much.
Right. Pleasure. Thank you so much.
And also to Adjunct Professor Jacqueline Rowarth.
Thank you very much, Brian.
Thank you very much.
But please, Brian, could I still have live access?
Yes.
Thank you very much.
And thank you very much. Just some drinks and refreshments out in the foyer there. I'd just like to just point out one thing, which is spiked by this conversation around nitrogen and the importance of clovers, legumes in the system. We, in 2028, will be celebrating our 150-year anniversary as a university. And one of the things that we have on the go is a sculpture to celebrate that, which is a sculpture to celebrate legumes and their contribution to the productivity and relevance in New Zealand, and the contribution of many of the people from Lincoln University and our associated partners directed towards that.
So there's the model directly.
No, it's not. But actually, Richard Lucas, Dick Lucas is here today, hands up Dick, who could probably provide some guidance to you. We are looking for contributions to this, to have this really well-established sculpture. We could just go outside Te Ita out here as a significant sort of recognition of the contribution of legumes and the role it has played in research at Lincoln University in celebration of 150 years. So if you want any more information, just have a quick chat to Dick and he'll give you some construct about what it actually is. Thank you very much for your time tonight.